In physics, we define energy as the ability to do work. Basically, whenever something's moving around, whether it's a planet, a football, or even a particle, it has energy. There are lots of different rules and laws and equations that help define different types of energy, but the two most general terms are kinetic energy, released through motion, or potential energy, that's being stored, kind of like a battery that isn't being used. Now, energy is important for a few reasons, like having electric lights in your home, or using fuel in our cars, or even sustaining our lives through the energy stored in the chemical bonds of the food we eat, stuff like that. But nowadays, whenever we talk about energy, usually something will come up about fossil fuels. These are organic substances that are very good at releasing a lot of energy when they're burned, which is extremely useful since there's so much of them that they're the main things we use to power our daily lives. But these fuels aren't the best because they release toxic pollutants into the air when we burn them. And there's a limited amount of them, so sooner or later we're gonna need a replacement. This is where a specific type of energy comes into play: nuclear energy. All forms of energy can be defined as either kinetic or potential, but nuclear energy refers to the cool type we get from the nucleus of an atom, specifically turning its mass into energy. Now, when talking nuclear, we can get it either from fission or fusion. So, fission is your more classical variety of nuclear physics. It's where we shoot a neutron at extreme speeds into a radioactive nucleus, causing it to split into two lighter nuclei and more neutrons. This is how nuclear power plants work, and how atom bombs go off. If the fission reaction is uncontrolled, energy is produced so fast it explodes. Fusion, on the other hand, is the younger, more sci-fi method of the two. It still converts mass to energy, but by smushing two lighter atoms together. Overall, mass is still lost, so we still get energy. Fission is neat in that it can produce more energy than fossil fuels, but it does need rare elements in order to work, like uranium and plutonium, and it produces its fair share of radioactive waste, which is arguably worse than most other pollutants. This is where fusion gets ultra cool, as it theoretically could produce even more energy than fission, using simple hydrogen, as in seawater hydrogen, and it wouldn't leave behind any nasty nuclear waste. The only problem is that combining atoms is a lot harder than splitting them. Since the nucleus of every atom is very dense and positively charged, they repel each other like magnets. As such, nuclear fusion is possible, but it currently takes more energy to make the reaction happen than it produces. It's a bummer, but scientists across the world are constantly working to find new ways to make fusion viable for the future. For the time being, I guess the only working fusion reactors are still the sun, the stars, and Iron Man's arc reactor.